I'm Sean Lavery with Dogma 1712, and I wanted to cover some basics about shafts, bearings, and Thunderhex. One of the big things that we've experienced this season after taking basically a full year away from our shop is a lot of students aren't quite familiar with some of the brand name terminology and what bearings are different, what distinguishes a half-inch round bearing from a half-inch Thunderhex bearing. So I wanted to cover some of those basics, because I'm sure there's plenty of other teams other than ours who have these same questions. So starting with the most basic, this is a half-inch round shaft, unkeyed. For this video, we're going to be talking about half-inch stuff because that's a common standard size in the first robotics competition, but this also applies to 3/8, quarter, 5/8, whatever size you choose. This half-inch round shaft doesn't have any keys or anything in it. It can be used as an axle, but it suffers some problems when it comes to power transmission. Namely, because there's no keys or no features to commit power, the only way that you can have a live axle, which is when your material turns with your axle, is through a press fit, where you have an interface or a press fit where you push really hard and it gets stuck on there physically from being slightly larger than the bore size on whatever you're attaching. Most cases with looser fits and free fits, this is going to spin around. That's okay for a dead axle, which is when your wheel or your sprocket or pulley spins around a fixed axle, but isn't great when you're looking to transmit power, rotational power, using a live axle, because as soon as you hit any kind of resistance, your axle turns independently. So in order to solve that, one of the first things engineers came up with was the concept of a keyway, where you have a groove, a keyway cut into the round axle and a piece of key stock. This can be used to allow transmission of torque on a round axle. When you place it on, and the keyway, ideally we press it enough that it can fit in there, and this is one of the challenges of keyway, you can then transmit torque as the ridges interface will lock the two pieces together like a key. Rotational transmission of torque with a live axle and a round shaft. But as you can see, there's a lot of concerns with that. Keyways don't always fit perfectly in there. It takes some filing and some tinkering to get it all together properly. You can lose key stock. Additionally, if you want to put a round bearing on there, the key stock, your round bearing is not going to be able to transmit any further along your length of your axle than when your key stock starts, because the round bearing does not have a keyway allowing to pass through. So one of the ways that FRC has attempted to solve that, the first robotics community, is through the use of hexagonal axles or hex axles. This can be done with any number of different shapes, but basically you use a shaped axle such that the shape of it allows the transmission of torque as things rotate. In this case, you'd have to have a hexagonal bore on your wheel, and you put it onto your hexagonal axle. And then as your axle turns, you can transmit live axle power to your wheel, your pulley, your sprocket, or whatever is on your axle. In this case, it also required hexagonal bore bearings, or to cut a shoulder into your axle such that they fit in a round bearing. Hexagonal bore bearings are just like a round bearing, but they have a hexagonal section cut into the inner race such that they fit around a hexagon. This has a couple different downsides, one being that bearing manufacturers are really, really good at making things that are round. They are less good at making things that have geometrical shapes inside of there other than being a round bore or a circle. As a result, the ratings on a hex bearing are lower than the ratings on the equivalent round bearings, both in terms of RPMs and load. Additionally, the alignment of hex can become a challenge during assembly, where you have to make sure that the hex lines up, and the hex lines up, and when you're putting things in blindly, it's not going to go quite as simply as that. As you feed it through your robot and try to get it to line up, it becomes a challenge several times. So one of the ways that Vex tried to solve that challenge was the introduction of Thunderhex. Thunderhex is a brand name. That's the first thing I'm going to put out there. It is not a technical term beyond the brand name. But what it is a 7075 aluminum hex axle with rounded corners. So as opposed to a true hex or a true hexagonal axle, which has sharp corners, Thunderhex has rounded corners. Thunderhex can still fit into a hex bearing if you'll line it up. It can still fit into a normal hex bearing. But what it also enables is it to fit into a Thunderhex bearing. So a Thunderhex bearing, despite the name Thunderhex, has no hexagonal features inside. It is a round bearing with a 13.75 millimeter inner diameter. So for both Hex and Thunderhex, the half-inch comes from flat to flat, but on the Thunderhex, the outside corner to outside rounded corner is 13.75 millimeters. So just a gentle, small amount of sanding, it can fit in this 13.75 millimeter Thunderhex bearing, and it can function just like any other round bearings that are fully rated, and the Thunderhex axle stays in there just perfectly, which really gets rid of the concerns of the lining shaft, gets rid of the concerns of derating, and allows you to use hex bore materials with round bearings effectively, getting the best of both worlds. So if there's one takeaway that I can give to my Dogma students and likely come in handy to a lot of other team students, it's that hex bearings are true hexagonal corners. Thunderhex bearings, despite having the word hex in there, are still a round bearing. They just have a slightly larger bore than a 1/2 inch round bearing. Thanks, guys. Good luck this build season.